This is your Chapter 8 exam review, and we're just going to go through the problems, and hopefully you find it helpful. Looking at number 1, it's talking about sample spaces and probability, and it says you flip a coin and draw a marble from a bag. You have 2 blue marbles and 2 green marbles. Find the number of possible outcomes, and then you want to list them. So first we flip a coin. So that could give me a heads or a tails. Those are like my first 2 options. And then if I flip heads, I could do blue, because there's 2 blue options, or green, because there's 2 green marble options. And this same thing is repeated. So if I flip tails, I could also pull a blue, or a green, or a green. So I could count 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 possible outcomes. And then it does ask us to list them, and I would not leave it in the tree that I drew up above. I would list them like I could do heads blue, heads blue, heads tail, or not blue, tails, heads green, and then I could also do tails blue, tails green, tails green. So those are my options for the outcomes. Number 2 is similar. It's just a different setup, and it says that we have the word happiness. So I'm just going to write this up here quick so we have a visual. So with the word happiness, it wants the probability of getting the letter S. And when I look at this, there are 9 total letters. That's the sample space. And out of that, I have 2 S's. So 2 out of 9 would be your answer. Sometimes you'll see it as a decimal. Sometimes you'll see it as a fraction. It could even be turned into a percent. So if we're just looking for all of those options, we could do 2/9, or it's roughly like 0.22 or 22%. So the representation of that can look differently. And then I have the probability that it's not the letter P. So there are 2 letters that are P, which means there's 7 that are not. So 7 out of 9. And I can do the same thing. I can represent it in a fraction. I could do 0.78 or about 78%. And that's with a little bit of rounding. So again, fraction, decimal, percent, you can see it represented different ways. Number 4. So number 4 is asking you to look at that 2-way table and determine what is the probability that a randomly selected resident who responded no. So probability of a resident that said no is from the west side. So it's really important to understand the order in which this is getting asked. It says the probability of a resident that said no. So that's the total. The people who said no is your total. That's going to be your denominator. And then from the west side is going to be your numerator out of that population. So the total amount of people who said no is 0.17. So if you add up both of the no's, 0.08 plus 0.09, you get 0.17. And out of those, the people that are from the west side is 0.09. So this would be my fraction. And if you look at the answer key, you made it into a decimal, so it's about 0.0 or 0.529. So again, the most important piece of number 4 is determining what is the total that we're talking about, and then the part of the total that goes on the numerator. Number 5, after an assembly, 220 boys and 270 girls responded to a survey. Of those, 200 boys and 230 girls said that the motivational speaker was impactful. Organize the results in a two-way table, and then find and interpret the frequencies. So we want to create the table, and so remember it looks like the one up above in example 4, but it has totals. Marginal frequencies are the total columns summarized. So that's what I'm going to take some time to create. I'm going to go ahead and put boys and girls on top and a total column. Okay, and then on the side, I'm going to put, yes, they found it motivational. No, they did not. And then the total. Okay, so let's fill some of this in. I'm going to read it again. So after an assembly, 220 boys and 270 girls responded to the survey. So those are the totals. So 230 boys, 220 boys and 270 girls responded, which is a total of 490 students. Okay, it says of those, 200 boys and 230 girls said it was yes, it was motivational. So 200 boys and 230 girls found it motivational, and that is a total of 430. And then we just do a little bit of math to figure out the no's. So that means there's 20 remaining no's for boys, 40 remaining no's for girls, and this is 60, and if you add down, we can make sure our totals match. So there's my table. That's what it's asking for. And then it says find and interpret the marginal frequencies. So these are just explanations of the total. So I'm just going to start 490 students were surveyed. Then I can say 430 of them said the speaker was motivational. And then I could say 60 said the speaker was not motivational. And then I could also go the other way, and I could say 220 boys were surveyed. And 270 girls were surveyed. So the order in which you state these doesn't matter, but again, the key here is that those marginal frequencies are all of our total columns, and you have to represent them with an explanation. Okay, moving on, we have two more problems, number 7 and number 8. Okay, so an inspector tests the routes of the rotors. Hello. An inspector tests rotors of helicopter drones. The two-way table is off to the side in your book. You probably want to have that open. and it says find and compare the results. Okay, so we're looking at the probability of, and then let's see, it's single rotor given it failed, and the probability of single rotor and it passed. So just a reminder, when you're given the horizontal or the vertical line, it's given that, and it refers to like the total. So I always put that these are the total, that's the denominator of each, and then this is the part of the total that you're looking for. So let's first find those probabilities, and then we can go ahead and compare them. So I'm going to find the amount that failed, and then how many of those were single. So I add up the total failed column, and that was 0.3. So the total failed column, and then of those, the single ones that failed were 0.2. And we can write this as 2/3 if we want to clean up the decimals, or you could say 67%. It doesn't really matter how you want to represent it, okay? But we do like to clean it up. And then the last one, so the part that passed, so I'm going to add up the total that passed, so that's 0.70. And out of the ones that passed, 0.3 of them were a single, 0.30. So I could write this as 3/7, or I could create that into a percent just to easier compare, and it's about 43%. So those are my results, and then it says to compare, so you could say the probability that, let me write this down. So the probability that you have a single that failed is higher than the single that passed. And you could use some cleaner sentences there, but you get the point. So we're just looking for the answers and then some sort of comparison of those two numbers. And I would just state which one is more likely. Number 8. So at a baseball game, 90% of guests received a coupon code and 30% of guests received the code and a bobblehead. What is the probability that a guest who receives the coupon code also receives the bobblehead? So right here, it's important, again, to identify the total. So I'm going to go ahead and just, number 8, we had 90% got a code, 30% got a code and bobblehead. So I'm just gonna convert, we put things as percents as decimals, so 0.3. And then it's asking us what is the probability that someone received a code also received a bobblehead. Okay, so again, received the code is the total, and so I'm going to put that in the denominator. So that's 0.9. 90% of people received a code. And then of those 90%, 30% receives a code, and a bobblehead. So again, you're finding out like the par over the total. And we like to clean this up. This would be 1/3. You could do that on your calculator. You could also say about 33%. Okay, again, we like to represent them differently, but if you are going to leave it as a fraction, we don't leave decimals in fractions. So you're going